Discussing metabolic pathways, and before we could really understand these complex series of reactions, we need to understand how enzymes work. Here we have two models of enzyme function. The top model is called the induced fit model. It is here. It is the more updated version. And the original model is down here, the lock and key model. So these two models are fairly similar in that the E, the enzyme, binds to the S, the substrate, and both of them have active sites for the substrate. And after they bind to the substrate, then they release the substrate and the substrate has been converted into product. The difference between the lock and the key model and the induced fit model is that the enzyme changes shape in the induced fit model, and it does not change shape at all in the lock and key model. And you'll notice also that the active site of the lock and key model reflects the shape of the substrate exactly, so the substrate can just fit into there exactly like a lock and key, whereas in the induced fit model, the active site does not exactly mirror the substrate. The takeaway from this is that in the induced fit model, both the enzyme and the substrate are going to change shape and or change chemically during the reaction, and that in the induced fit model, it is the transition state of the substrate which best binds or binds strongest to the enzyme. So as we could see, the enzyme and the substrate fit exactly together when the substrate is kind of being stretched like this. So this is meant to show that the substrate is being chemically altered and it's in the process of that chemical reaction, which is going to result in the production of the product. Again, in the lock and key model, the enzyme did not change shape and there was no focus on the transition state, as well as the active site being exactly mirrored to the substrate in the enzyme's natural state. So the induced fit model, again, is the one that we now have a lot of data, so we could be confident that this is closer to what actually occurs on the molecular level.